My name is Jeff Smith. I'm a wireless consulting system engineer for Cisco Systems. In today's Tech Talk, we're going to discuss the advantages of the new AP1250 in a legacy wireless environment. So I'm here in San Jose in a new building that we're getting ready to occupy here in the next few months. We took the advantage of this new building under construction to actually test the advantages of the AP1250 versus the AP1240 in a legacy wireless environment. This building has a number of the typical things you expect to find in modern office buildings. You see cubicles, you'll see elevator shafts in the middle of the building, you'll see stairwells, electrical panels, a number of RF obstructions that could interfere with the performance of the wireless network. We're going to look at how the two APs perform in this environment. So let's step over here and look at the AP1250 and 1240 and discuss the differences between these two access points. Here we are with the two access points we're going to be testing today. The AP1240. The AP1240 has 4 antennas, 2 for each band. It uses diversity, which means that only one antenna is transmitting or receiving at a time for each band. We'll compare that to the AP1250, which you notice has 6 antennas, 3 for each band. It uses a new technology called multiple input, multiple output, or MIMO for short. With 3 antennas for each band, it's transmitting and receiving on multiple antennas at one time. So let's delve a little bit deeper into how MIMO works with this new AP1250. This diagram is illustrating a typical office environment like we're in today with cubicles. We have the transmitter down here at the bottom, which is transmitting a signal, and multiple copies of that same signal arrive at the receiver. So you have copies being delayed going through this front wall, you have copies bouncing off the right wall here, and then you have copies bouncing off the back wall, as well as you potentially have some sort of object moving through that space, creating additional reflections as it moves through that space. So the AP1250 takes advantage of those reflections, or commonly called multipath, in order to increase the signal strength. Let's look at specifically the technology in the AP1250 to do this. So on the receive side, so the AP1240, it can only receive one copy of that signal and decipher it at a time. Compare that to the AP1250 with its MIMO support. It has multiple antennas receiving multiple copies of that transmission, combining them to create a much, much stronger signal as compared to the AP1240. And the concept that it's using there is called maximum ratio combining, where this signal strength is much stronger of the combined signals that any one antenna hears. Now, on the receive side for the client, the AP1240 is sending one copy of that signal out of one transmitter, where the AP1250 is transmitting on multiple antennas, creating a much stronger receive signal at the client. I'm going to now actually demonstrate for you how the AP1250 and 1240 perform in this live environment. So please walk with me as I connect to these APs and show you the coverage and signal strength as we go through this environment. Here I am with my laptop, which has a legacy Wi-Fi adapter. It only supports A, B, and G. It has no 802.11n support. If you look, you'll see I have the AP1240 broadcasting SSID as well as the AP1250. I'm going to connect to the AP1240. And at the same time here, you'll see I'm running a continuous ping, showing that we have connectivity, so we can watch the connectivity as I walk through the building, doing a coverage test here. And I'm also going to run a throughput test with Chariot. And here I've started Chariot, and we're doing a data throughput test as I walk through the building here. So please follow me as I walk to the other side of the elevator shaft to check coverage.
Using the Planner application from WCS, you can visually predict the RF coverage.
As you can see, we've lost connectivity with the AP1240. So the client adapter driver is showing we're out of range because of this obstruction. Now we're on the other side of this elevator shaft that we've lost complete connectivity with the AP1240. So let's retry the same test using AP1250 with this client. So with the same laptop, I'm connecting this time to the AP1250, and I'm going to walk behind that elevator again to that same difficult coverage area to see how it performs now talking to the AP1250. So please follow me. As you can see, we still have connectivity with the AP1250 to this client. I'm in the exact same spot that I lost connectivity when I was connected to the AP1240. As you can see, the pings are successful, and I'm getting an average throughput of just a little over 17 megabits per second. This demonstrates the superiority of the AP1250 in making legacy Wi-Fi clients work better in existing buildings.